Hey everybody, with the re-release of Ghost of Tsushima on PC, I've been thinking about making a video series about the Bezier curve grass that was used in the game based on the GDC presentation that they did, basically showing how you could use the same techniques to create completely procedural grass blades in Unreal Engine. This isn't going to necessarily replicate every technique that used because some of that stuff is kind of unnecessary in Unreal, particularly regarding the compute shaders and things like that in terms of how they procedurally position the grass in the world. Ultimately, Unreal already has foliage systems, and there's no reason to completely reinvent the wheel. But the shape of the blade of the grass in Ghost of Tsushima is defined by Bezier curves, which you can see that we have right here. So I can, inside the shader, adjust the control points of these Bezier curves to get different shapes of grass completely procedurally. And then that can simply be rotated in the world to get any other effect. So how this essentially works is if we look at the Bezier curve, right, we get three control points. And you can see that the curve that's defined by those control points can roughly represent the profile of a blade of grass. So all we need is a way of defining how we position these points, and then we need to be able to use those points to apply a world position offset. So the way that we're going to approach this is by positioning the points flat along a plane like this. And then in the shader, all we have to do to create basically any curve we want is tell it, and this is how they did it, and at least how they defined their curves in Ghost of Tsushima as well, is we have to define a midpoint that our second control point will be on along the length of our blade. And then we define the amount of the curve, which will dictate the amount that this has bent away from the length. We don't really need to rotate this control point at all because we can achieve any of those possible positions simply by rotating the entire transform of the grass. So there's really not a whole lot of reason to alter that. And so you can see here that I've got exactly that, right? So I've got the midpoint, which moves that second control point along the length that goes from point 0 to point 2, and then the curve amount that offsets the blade in the y direction on this graph here. And so Bezier curves, we can see here is, there's a formula for, in this case, I'm using a quadratic Bezier curve. In the presentation, they said they used cubic Bezier curves, but in all of the materials, the slides they showed, it actually appeared as though it was a quadratic curve. So I don't know if maybe I missed something there. Ultimately, a cubic curve would work exactly the same way. You would just need an additional control point, which seems unnecessary. And they only described defining the beginning, middle, and end. So I'm assuming that they, in fact, actually used a quadratic curve. But what we can see here is that the formula for a quadratic curve can be interpreted as a linear interpolant of the corresponding points of the curve from 0 to 1 and 1 to 2. So basically, it's just a bunch of lerps. So what we can do is define the amount of our curve using simply just a linear interpolate. But first, how do we get our mesh? So what this is, if I actually take this mesh here, and we're going to go ahead and copy it, I'm going to remove this material from it, you'll find that the mesh that I'm using is actually just a plane, and that's it. So effectively what I did for this particular mesh is I went into the modeling tools, I added a rectangle, I adjusted its pivot, and also when I created it, I guess I should have done that earlier. When I created it, I added subdivisions so that if we look at the wireframe here, you can see in this case there's a series of 8 vertices along the x-axis and no subdivisions on the y-axis. So let's go ahead and delete that. We don't need those. So that's all that this is. And we can go into wireframe view as well here and see that. That's true for this as well. And what's happening is the shader is shrinking and shaping the plane along its x-axis. If I lay it down, so you'll see the length of the blade will be running along the x-axis, and the width of the blade will be running along the y-axis, and the curvature of the blade will be the z-axis. So if we go back to our Desmos here, essentially, again, we have this basic idea. So if this is our x-axis, we're looking exactly at the side of the blade. The y-axis is non-existent in this case because it's a 2D function. And then the z-axis is actually the y-axis. So when we go into our material, let's go ahead and create a new material and assign it to our plane. What we need to do is first grab our texture coordinates, or I guess I could just use the shortcut key, right? And then we're going to grab our component mask, and we are going to grab and look at the R direction. So we can see that we have a gradient running from the base of our blade of grass to the tip. And so this will define the t in our function, which will determine what point along the Bezier curve formula we're ultimately sampling. So we're going to go ahead and just for the sake of this, I'm going to throw in a named reroute node. I'm going to call this t. And then we need to define our control points. So we'll take 3 control points. And for now, I'm just going to hard code these as 0, 0, 0, 1, and 1, 1, which will give us a curve that looks like 0, 0, 0, 1, and 1, 1 will look like this. And we now need to set up our Bezier function. So we're going to grab 0, 0 and 0, 1. So interpolate between points 1 and 0 and 1. And we're going to go ahead and named route nodes here. So this will be the 0. This will be the 1. This will be P2. And we will interpolate between P1 and go away, and P2. And then we need to interpolate between our interpolated points. So we will grab one more linear interpolate. And then all of these will use t as their alpha. So this will give us our curve, which won't look like much right now. But if we go ahead and plug this into our WPO, And then we're actually going to multiply this by 100, just because I put in ones and we want to get this into unreal scale. Now you can see that we have a curve, but it looks wrong, right? And that's because we're using x and y, but as I mentioned before, we actually need to convert our curve into x and z. So we're going to go ahead and use a break float 2. And we are going to add in a make float 3. So this will allow us to take our r, which will stay our x. So x stays x. Our y, we need to be z. And for now, we'll leave nothing in the y. And so what this will do is it'll turn our curve into the axis that we want it to be, right? But it still doesn't look quite like our graph, right? We should have a curve that operates in just a 1x1 square, but this is twice as long. And the reason for that is the coordinates are currently being added to the original world position along the x-axis, which is doubling the length. So we need to take t, so grab our named reroute node, and we're going to go ahead and subtract. We're going to grab an append as well. We're going to subtract this from the original UV coordinate. So this will basically take away the original position, right? So if we go ahead and apply this, it'll shrink it to the correct size, right? And if we look at what this is alone, this is basically just taking away, right? If we just went this, it would just disappear, right? We're just eliminating it and then adding back in the curve function, which will get us the right shape. Let's go ahead and make our mesh two-sided. And for now, let's make it unlit. Okay. So now we have a curve, and we can define the shape of our curve. And so the next thing we want to do is give our curve some profile, right? Define the blade's profile so that it actually looks like a blade of grass instead of just a plane. Now, if you use an actual mesh, if you imported a blade-shaped piece of grass with the right UV layout to get the same result, you might not need to do this, but I want to do this completely procedurally. So we know that the width of our blade is determined by our y-axis here. So we can create some shape for it by taking another mask, and we're going to grab our G. And so if we look at our G, you can see that this is going to give us a coordinate along the length of the grass, or the width of the grass. And if we subtract 0.5 from it, this will give us our center line. So everything on the right is positive, everything on the left is negative. And then if we were to multiply this by some value, we would be able to change the size of our grass here, right? So negative 50 would cut it in half. But we don't necessarily want negative 50 to cut it in half. What I would prefer is for the width parameter to define the actual width of the blade of grass. So we need to do something similar to what we did here, right? We need to take our coordinates, multiply them by our scale factor here, which is making things uniform. And then we're going to subtract our scaled UV coordinates by 0, from 0 rather, and this should just cause it to shrink into nothingness. And then we're going to add back in our manually defined scale. And so now, if I go to 50, it widens it to 50. If I go to 100, it widens it to 100. And 0 means it's 0 units wide. So I have precise control over the width of the blade. But it still ultimately looks like a a strip, a rectangle, and not a blade of grass. So what we need to do next is have a way to give it some more shape. And there's lots of ways that you could do this, but the way that I will show here will be to continue to use the UV coordinates, right? So for example, we have our RUVs, and if we just, which is T, so if we take our T again, and we multiply our width by T, now we're getting a triangle, right? But it's upside down, so we're going to go ahead and take a 1 minus, and now we have a blade of grass, and when we change the width of the grass, we are only changing the width at the base, and the tip remains going to a singular point, which is looking good. Now, we can introduce some more complex shape to this grass by changing the width at other points as well, not just the base. So what I did in this material here is give it an adjustable base, so I can adjust how wide the base is, but also adjust the width of the blade, so I can give it kind of a more spear shape. So if we want to do that, then we can essentially, as you can see here, add back in some width. So if I take T, and this time not with a 1 minus, and then we're going to add this here, and then multiply that. Now you can see that it's going to 0 at both the tip and the base, but as I expand the base, the tip stays at 0. And then I can increase the width of the blade, but I can still shrink down the tip. And this will allow me to give kind of that spearhead or arrowhead spear shape to the grass. So we're going to go ahead and set this to maybe 0.15 and this to 25 for this blade. And then for now, let's go ahead and give it color. All right. So now we have our grass looking kind of like the shape of grass. We've got curvature being defined, but at this point in time, the curvature is simply just hard-coded, right? So basically it just says, this is the shape of the grass. But what we really want is to be able to procedurally define the grass. And so there's a handful of different ways that we could do that. In my example here, again, I said we're just going to lay it down flat, and then we can translate this midpoint along and then extrude it out. So if we wanted to do that, for example, we could set our coordinate for point 2 at 0 and 1, and our, 1 and 0 rather. And so this is going to cause it to travel flat along the ground, and then this should, by default be at 0.5 and 1, and that's obviously going to have some z fighting, but yeah. And also, a side note, I guess I've displaced this from its origin, and that's because of this subtraction. I shouldn't be subtracting from 0. I should be subtracting from half of what we've divided by, because we want it to be at the midpoint. So if I just divide that by 2, or subtract the y coordinates from 50 instead of from 0, that will put that right back at the origin. But in any case, now I've got a flat blade of grass. But what we need too is another append vector. Now we're going to procedurally define our second control point instead of doing it explicitly. So we are going to create 2 parameters. This is going to be our midpoints. And we're going to set that to be in the range of 0 to 1, although theoretically you could go outside of that range if you want. And this is going to be our curve. So now, if I adjust the curve, you'll see our grass blade is curving, and our midpoint is being adjusted back and forth, which is great. So now we can really define the shape of our grass. There's no reason to ever adjust, maybe not no reason, but there's not much reason to actually adjust the first and the base point, because if I wanted to adjust the first point, all that's really going to do is either lengthen the whole blade or rotate the whole blade. And we can already do that by changing the blade's transformation, which, speaking of, we need to go ahead and transform our world position offset. We're going to transform it from instance and particle space to world space. In particular, because usually when you're creating a blade of grass, you're going to be using instances. So we can't just use local space. We need to use instance and particle space. So now with that done, as I rotate my blade of grass, this is effectively like changing where the third control point is. So there isn't really any reason to explicitly control that in the shader at this point in time. Although, again, you theoretically could. All you'd have to do is change this from a constant to a variable. And you might want to do that for a variety of reasons, but just for the purpose of this, it's good enough. So now we've accomplished most of what we set out to do, right? So we have a way of procedurally defining the shape of our grass, both in its curvature and its shape, like the width. We, let's see here, we still need to do a couple of things, which we'll cover in a future video, which is most importantly, adjusting the normals. So as it currently stands, if we go ahead and go to our buffer visualization and we look at our world normal, this is unlit, so it doesn't have any, but if I go put this to default lit, you'll see that the normal is just facing up. If I change the rotation, this is just a flat surface. It still thinks it's a plane. So we need to determine our normals. Fortunately, we can do that with our Bezier curve formula here. So we can see that we have our derivative plainly stated here in the Wikipedia article. And with the derivative, we can find the normal of our curve. So that's the main thing. We might look at some of the other features if there's enough interest, but we'll definitely at least do one more video to cover correcting the normals. But I think that should be it for this one. Thanks for watching, and see you next time.